So, good morning to all the participant. Welcome to the day 9, session 1. So, as for the program schedule, actually, I need to discuss about the public blockchain system followed by the private blockchain system. But due to time limitation, I'll only focus on the public blockchain system and we'll see also some of the coding once we cover this particular lecture. I'll also tell you how to generate a random key, how to generate a public key, how to generate a private key, and how to generate an address with a particular text, how you can generate its SHA 256 key. These things we will discuss followed by my lecture, right? So what actually we are going to discuss today, uh, first we will see the different types of blockchain system. Also, I told you about in previous class related to public and private blockchain, permission-less and permission blockchain, consortium blockchain, hybrid blockchain. But in general, we say this is two type. One is called as public blockchain system, another is called as private blockchain system. So we'll revisit what is the concept of public and private blockchain system, and we'll compare them first. And when to use the public blockchain, that is very much important, right? You need to determine if you want to participate in the public say blockchain, uh, whether you are going to use public blockchain or any different type of blockchain. So for this, we have a flow chart. You have to decide on a couple of questions. By looking into such questions, you can determine whether to go for public blockchain or you go for the private blockchain, or you can also see in your particular problem, blockchain is not at all applicable, right? Not everywhere you can apply the blockchain, right? You cannot bring anything, any problem into blockchain and can say that we can do a blockchain for this particular problem. So we'll see different cases like in which case it is falling under permission-less blockchain, which case it is falling under public permission blockchain and private permission blockchain, and at least in which case it is not at all a blockchain. That is called as when to use the blockchain. Then every technology has a particular layers, right? Like that here also we have a blockchain layer. So we have three different layers. You can see where Bitcoin lies, where we have tokens, and where we have blockchain technology. Then we'll see the details about the Bitcoin. Especially, I'll start with the Bitcoin rate and how it was coined, what is the rate of Bitcoin, how it is increasing day by day. Then we'll see about the Bitcoin mining. So in Bitcoin mining, we'll see different type of nodes, different type of miners, how a mining is different from the miners, and also we'll see the mining pools. And we will also see there are different types of Bitcoin mining is also there. We call sometimes a Bitcoin mining is of two types by saying it is a software mining, another is a hardware mining. Hardware means CPU is a hardware, GPU is hardware, FPGA is also a hardware, ASIC is a hardware. But when we talk about software mining, we talk about cloud mining or we talk about pool mining. So on that basis, the Bitcoin mining is divided into two different types. Then we'll go for proof of work, one of the very famous consensus mechanism, and we'll see detailed about the hash case. Right? I'll tell you about the process, how to get this hash case. Then one of the important part in the blockchain header that is called as a Merkle root. So we'll see how to create a Merkle root through two different numerical example, and also we'll see how hash case mapping done. Right? What is the underlying technology between hash case mapping? Also, we'll see two different example for hash case mapping. The next one we'll discuss about the mem pool. Mem pool is nothing but the memory pool. So whenever a particular transaction is not confirmed in the blockchain, Like whenever you are proposing a particular block or a particular transaction, it is not going to immediately accept it. It will be in the unconfirmed state, right? So in unconfirmed phase, these transactions are put in the memory pool. Once it is confirmed, it will be removed from the memory pool. So we maintain that in the form of a memory pool. So we'll see how a miner actually choose some transaction from the mem pool. And what happen if the hash is not matched? Like we say in machine learning, we say training and testing. Here we also say that our test has and a target has. If test has is not matching with the target has, then what we are going to do in the mem pool? Followed by we'll see the block propagation and relay, right? Suppose a transaction is proposed, right? How many consensus is required? Okay, that is called as a propagation or relay. How that is going to be reflected in the blockchain? That is called as block propagation and relay that we'll discuss. Then I'll tell you about one of the popular programming language for Bitcoin that is called as fork. So through for this is a very simple language through which you can write code for Bitcoin, which we call as Bitcoin script. So I give you two different example of fork so that you will come to know that how people are writing code in for Bitcoin, right, or in blockchain. And the last part we are going to discuss what kind of transactions are happen in the Bitcoin network in much more detail. So you can expect this thing in this particular lecture. And after covering this part, I'll show you some part coding so that you can relate the theory with the coding concept. So let us start with the basic one, that is what is the difference between the public blockchain system and another is called as private blockchain system. Like if you see the Gmail, our very famous email, right? Google Mail, each and every individuals are using Google services. They have Gmail, right? Or they are using a Google account. So anybody can create a Google account and anybody can write an email, anybody can receive a particular email. So this is very common, right? So we can call this one as a public system. But if that email ID is restricted to a particular organization, like if you restrict it to NIT Warangal, or let it be your organization where you are studying or where you are a faculty member, then we call that as a private blockchain system. Private system, not blockchain system, it is a private system. So what we can see in private system, nobody can enter and join in the system. So in order to be a part of the private system, you have to be a member of that particular system. So in the similar fashion, like this email system, if you compare public blockchain system with private blockchain system, you will see in public blockchain system, anybody can join. You cannot stop an individual to join into the blockchain network. And in fact, each and every peer or each and every user is treated equally in the case of public blockchain system. But when you go for private blockchain, like I told you, private email ID, right? Nobody can create a private email ID if it is not associated with your organization, right? So anyone cannot join in the private blockchain network. Okay, they cannot join in the network until unless they have some permission. Like they may be by invitation or they may have to first approach. Once it is approved, then only that particular member can be a part of your blockchain. But public such restriction is not there. So we can say in public blockchain system, users are anonymous and one user may not be aware of other user. So anybody can join means again it is security is a major concern, right? If anybody is going to a malicious, people can join in the network. That also may happen in the case of public blockchain. Although the distributed ledger is going to protect us, but malicious user also can join the network. But when you go for private blockchain, the prerequisite condition for it is you should be a member of that particular blockchain, right? So if you are a part of a public blockchain, then you can download a copy of the ledger Like tomorrow, a new person can join, a malicious user can also join and download a copy of the ledger. So a copy of ledger with each and every person. But when you go for a private blockchain, only the member who is associated with that private blockchain, they can only download the copy of the ledger. Other persons cannot get the copy of that particular ledger. One of the example, if I say, nowadays we are using Google spreadsheet or Google Excel. Okay, and suppose that Excel sheet is shared among couple of people. Okay, and assume that the deletion is not possible. So whenever you are making a particular transaction, you have to make a entry in that particular Google sheet, right? So in each row represents one transaction. So if you want to add a particular transaction, you have to simply add it as a new row, right? And once you add a particular transaction, that is going to be shown to each and every person who has that particular spreadsheet, right? That is called a shared with all, right? So anybody can see what transaction you are making or what other people are also doing. You can also see that particular thing. That is called as simply a public blockchain system. Anybody can participate. Anybody having that particular link of Google spreadsheet, they can participate in the network, right? But if it is restricted to two, three people, only the two, three people can only see that particular transactions, right? That can be treated as a private blockchain. But if the link is open to all, then we call that as a public blockchain system. So the real life example of public blockchain system, Bitcoin is one of the popular example. And if you see the number of transaction, which is noticed in the March 2019, that every day we have 3 lakh transaction in the Bitcoin, right? Similarly, another public blockchain system is called as Ethereum. It was developed by Vitalik Buterin in 2019, but this is not the pseudonym, this is the actual name. And you can see this is also a example of public blockchain system. But in comparison to Bitcoin, Ethereum is not that much popular, right? You can be say that it is a second cryptocurrency, right? Not like the Bitcoin, right? Now, let us decide that when to use public blockchain. You cannot apply public blockchain in each and every case. In fact, this flowchart will give you an idea that whether to use a blockchain technology or not. Okay, whether applying blockchain technology in your respective domain, is it feasible or not? So let us start with some questionnaires, right? So with these questionnaires, you will come to know whether you want to use public blockchain or private blockchain or permissionless or permission or not at all the blockchain. So the first question says that do you need to store the state? Like you are making a particular transaction, you want to keep in some storage, right? That is called as a state. A state not only contains your transaction, it contains many people's transaction. So if you want to keep such transactions, okay, in some storage, or you want it should be available in the distributed ledger, right? That you have to decide. So do you need to store the state? If your answer is no, I don't want to store this thing in some state, then you can say don't use blockchain. Only when you can use the blockchain if you want to store the transactions and everything in the form of a state. Now come to the second question. If it is yes, we will go for the second question. Second question there is that are there multiple writer? You are not only the person who is making transaction, but other people are also doing transaction in parallel with you, right? So there are multiple writers. Not only you are changing a particular variable, but other people are also doing that one. But if there is no multiple writer, don't use blockchain. But if there are multiple writers are there, then only you have to go for blockchain. Now, the third question, if it is yes, first two question, if your answer is yes, then third question I'll ask you, can you use an always online TTP? TTP stands for trusted third party. Like bank is a trusted third party, right? So do you think a third party is required while you are making a transaction? If your answer is yes, you need a trusted third party. Don't use blockchain, because blockchain concept says that you have to, there is no third party. Forget about the trusted party, but there is no third party, right? So can you use an always online TTP? The answer is no. Then only you can use the blockchain. Now the fourth question is that, are all writers known? Like I told you, multiple people are doing transaction, right? If all writers are known, those people who are altering the transaction or updating the transaction. Altering is not a correct word in the case of blockchain, but those who want to append a transaction, those who want to update the transaction, they are known to you. If your answer is yes, again you are heading towards that is not a blockchain. But are all writers known? If it is not, your answer is no. You don't know who is writing with you, right? Who is appending a particular transaction with you, then you can go for permissionless blockchain. Okay, because you don't know who is the person. So it is a public blockchain only, right? But it is a permissionless blockchain. But if the question again we are asking here, are all writers trusted? Yes, all writers are trusted. They are genuine user, then don't go for blockchain, right? In blockchain, we assume that any anonymous people can join, right? Anybody can join, right? That's why if writers are trusted, don't use blockchain. And if all writers are all writers trusted is no, then we are heading towards a two different type of blockchain. We say that is public permissioned blockchain, another is called as private permissioned blockchain. See, so you can say public blockchain is again divided into two types. One is called as a public permissionless blockchain, public permissioned blockchain, right? It is another type of classification under public blockchain system. And the last question we are asking here is public verifiability required? Public verification is required. If your answer is yes, then you are using public blockchain. Is public verifiability is not required, then who is going to verify, you may ask me, right? So some selected members, those who are present in your private blockchain, they are only going to verify. Like there are some government agencies are there, or some peoples who have started their blockchain, they only can verify. Normal member cannot verify that one. Then you can go for private permission blockchain. So the idea of showing this particular blockchain is to decide when to use public blockchain or when to use private blockchain. Again, in the public case also, we have seen permissionless blockchain and permission blockchain. Okay, and also we have seen in which case the blockchain is not at all applicable. Now, if you want to find the difference between this permissionless and blockchain and public permission blockchain, the definition looks similar because both case you have public. Okay, here also you have public. Right? Although we call it permissionless, but it is called as public permissionless blockchain. Right? So the difference is that if you go for permissionless, nobody is there to give you permission. So there is multiple writers are there, but we cannot use always online TTP. Trusted third party is not required in the case of blockchain. This type of blockchain, right? And not all writers are known. As it is public, you don't know everyone, right? But when you go for public, but permission, this is permission. You have to take permission to be a part of that particular chain. There also you don't have any trusted third party, but the writers are known because it is permission. Those who are the member of that particular blockchain, everybody know each other. They know that these are the people who is going to be the writer of that particular blockchain. And here also you can see all the users cannot be trusted because it is public. Both cases is public. So both case you will not believe on the user. And public verifiability is required here because it is permission. Public verifiability is not required in the case of permissionless blockchain. So in that way, Based upon the number of writer, based upon the profile verifiability, you can distinguish the permission blockchain versus permissioned blockchain, right? Now, come to the next concept that is called as layer. Each and every technology is having a different kind of layers, right? It is relying on various underlying technology, right? Like you can see one of the very popular model we are using in our network that is called as OSI ISO reference model. So it is a 7-layer model. So each layer has given some kind of responsibility. In the similar fashion, the blockchain layer is also divided into 3 different layers, right? So you can also see in layer 1, you have technology. The technology is our blockchain. Layer 2 consists of some protocol or we can say coin. Third layer is called as a token. So ultimately, this layer is giving us the relationship between blockchain, that is technology, protocol and coin. Coin is nothing but your cryptocurrency and token. The relationship of these things you can see in the blockchain layer. Now, if you come to layer 2, what we have? We have Bitcoin, we have Litecoin also, we have Ethereum, we have Ripple. So these are the different cryptocurrencies, right? Which is very much popular. It is not the complete list. You can find a lot many coin and cryptocurrencies are there. But along with that, the protocol is important because protocol will give you a set of rules and regulations in what way they are connected or in what way you are going to uh, make a validation that is depends upon the protocol. And these protocols are not a new protocols. Like you can take HTTP is one of the protocol, HTTPS that we call it a secure hypertext transfer uh, protocol, or you can go for TCP, transmission control protocol, or IP, internet protocol. These protocols you are also can use in the layer 2. Now coming to token 3, like one of the uh, uh, popular term in this faculty development program is related to smart contract, right? So this is nothing but an underlying contract. So that is also a token. Token is basically a symbol for an underlying contract. Like if you look into Ethereum, which is a very popular one after Bitcoin, it is 100 of token. And the token name may be TRX, which we call as Tron. SNT stands for status, PPT stands for populace, and PNB stands for provenance. These all are called as a different kind of token. Like banking system also sometimes they issue the token to avoid the rush, right? So some technologies, some cryptocurrencies having tokens, such a system. Like Ethereum case also you can see these are the popular tokens. But what about Bitcoin and Ripple? Bitcoin and Ripple case you will not find any token. Token is there in the case of Ethereum only. Now, as I said, Bitcoin and Ethereum are the two popular public blockchain system. So you can say Ethereum is the second biggest cryptocurrency, and first or biggest cryptocurrency is your Bitcoin. So what is the main purpose of going for Ethereum is that Ethereum allows creating decentralized and open to all solutions for various sectors. So the purpose of Ethereum, as I mentioned, that Vitalik Buterin started, he coined this word Ethereum, right? He mentioned that it is also decentralized. It is also open to all solutions, means anybody can participate. That's why it is called as public blockchain system. But main application of Ethereum is called as crowdsourcing. Crowdsourcing means many people, like if you see NGOs, if you see the people who is collecting information from the ground level and inform to the government, or WikiLeaks, right? Or media reporters, these all are coming under the crowdsourcing. So many people voluntarily do crowdsourcing, and many people also do crowdsourcing for some money purpose, right? So that is also one of the application of Ethereum. Similarly, we assume that in future the voting is also going to be done by the help of Ethereum, right? Voting for democracy, right? There is no need to go to you can say to the voting center to give the vote. Voting can be done by sitting in your home also. Next is we have a recommendation system. In recommendation system, we are giving rating, okay, for each and every movie. So there also we can use Ethereum. So what this founder of this Ethereum mentioned that though this above application like crowdsourcing, voting, public rating engine for movies, the application of Ethereum are successful, right? Somehow it is successful. Like voting is not implemented in our country, but you can see for other purpose also you can use this voting mechanism, which is there in the Ethereum, right? So the best application of Ethereum is yet to happen. So the actual application of Ethereum is coming in the upcoming years, right? And if you look into this application, it is very, very similar as our www, that is World Wide Web, or you can say JavaScript. Nowadays we are using this thing, right, for our web development. So Ethereum is reached till now up to www and JavaScript. Okay, just like these technologies are there from late 90s, right? So Ethereum is not mature till now, but by the time it will mature, it has a very huge application which will open to provide you open to all solution. Now, if you see the Bitcoin of a blockchain, the domain bitcoin.org that you can visit, which was registered in the month of August 2008, and the person Satoshi Naga from Japan, he published a research paper on Bitcoin on 31st October 2008, and first time Bitcoin is introduced now in the world in the year of 2009. And who actually manages this by Bitcoin? Who is going to validate? The miner has to validate this thing, right? So people who create the Bitcoin, they are called as miners. Although miners are also used, can create a block and can validate a particular block also. So there is another currency you can say that is Bitcoin, right? Which is a BTC. Similarly, if you compare one BTC, which is equivalent to 10 crore Satoshi, and also the US equivalent of earlier, if you see, one Bitcoin is less than one US dollar, right? But over a period of time, you can see the Bitcoin cost is increased, right? Earlier it is very less, right? But nowadays Bitcoin cost is very, very high. Like you can say it is a 5-digit US dollar is equal to one Bitcoin. Like here you can see one Satoshi is equal to 0.0000007 zeros and one. That is the US dollar equivalent. Similarly, 10 is nothing but 60.601. It is the equivalent. And 10 crore Satoshi is equivalent to 1 crore, one BTC, right? So those people who are unable to purchase the Bitcoin, they have to purchase the Satoshi, right? Because it is a small unit, but Bitcoin is a very large unit. So in that way, you can purchase it. Now, if you look into the trend, right, starting from 2010 to 2019. So in 2010, if you see, one Bitcoin is equal to 0.09 USD. That's why I mentioned that the cost of the Bitcoin is less than 1 USD, right? But over a period of time, like if you see 2012, the Bitcoin price is equal to 5.27 USD, and 2017 it has reached to the highest one, that is 19,498 USD, right? But after 2017, okay, due to market problem or due to other technical factors, right, suddenly the price is also now decreasing. Like here you can see from 19,498 USD to it is reduced to 13,412 USD, right? Like you may aware of this ransom virus, right? Somebody injected the ransom virus in the internet or www, and this particular virus affected 150 countries, right? So it is just like you can say it is also epidemic, right? So once you inject the virus from one computer, if it is spread it towards the nearby countries, then it is called as epidemic, right? But if it is later it is covered whole world, then we call it the pandemic, right? Like coronavirus is also treated as a pandemic. So in computer virus, that is ransom, it is spreaded to 150 countries, and those people who have injected this virus in the internet, they demanded thousands of Bitcoin. Okay, they have not asked the money in terms of INR. They have not asked in the money in the pace of euro. They have not asked the money in the dollar. Rather than they ask the money in the Bitcoin. Okay. Once they receive this amount, then they say that we are going to remove this virus from these different countries or from different computer system. So the cost of the Bitcoin is varies with respect to different, you can say different years, different day, different second. The price is also varying. Now come to the Bitcoin mining. How to go for the process of mining? Before going to the process of mining, you should know what is the difference between the miner and another is mining. Miner is not same as miners, right? Miners, you know that miners in the case of Bitcoin, they actually validate the new transaction and they add them into the blockchain ledger. Like whenever you have a new transaction, in order to validate the new transaction, we have miners. And later, once it is properly validated, we add them into the blockchain ledger. Now, if you go for the process of mining, so process of mining means once a transaction is proposed, you have to validate it, right? Who is going to validate it? Miner has to validate it. How miner is going to validate it? Miner has to use the computer's power. That is, you can say high performance power, high processing power. Computers are having computer graphics card through which it has to solve a very complex mathematical problem, or you can say puzzle, or using cryptographic hash function in order to validate that particular transaction. So in order to perform the process of mining, you require electricity, power consumption, that is your electricity, and heat is also generated from that particular computer system. That's why the first miner who have solved this puzzle is rewarded, right? So you can see in the mining process we have nodes and we have miners. So nodes and miners, they are not same. Okay, any node can propose a particular transaction, but miner has to validate that particular transaction. You can consider in a typical scenario they are same, but their responsibility is different. And we have a mining pool. Just I mentioned about the memory pool, or we call that as a mem pool. So those transactions are not authenticated, are not confirmed. They are put in that particular pool, and later point of time, once it is validated, it is going to remove from that particular pool. Now you can see here a simple calculation will give you the idea of the Bitcoin mining. Like I mentioned, if you say it is 256 bit, right? 256 bit means it is, if you represent each hex digit, right, by 4, so it is nothing but 64 hex digit. Okay, so a hash contains 64 hash digit or 256 bit of 256 bit of binary, right? And each digit is either 0 to 9 or A to F because it is in hexadecimal system. Now, if you consider the hash set, right, like all possible number of hashes, like if you do a small change, then you can see that the output is also going to be changed. Like if I write OK, then if I write OK space, the hash value is changed. So, but total number of hash bit is 64 hash digit. So let us assume that a total of n different types of possible hash we can generate, right? So H it is 64 and each digit is of any one of these 16 digit. Either it is 0 to 9 or it is A to F. So population hash set consists of 16 to the power 64. This 64 is nothing but hex digit and 16 is nothing but A to F and 0 to 9. So this is a population hash set. Population hash set consists of all possible hashes, right? Now, if you come to the target hash, so we have seen in Genesis block, the target hash, if you see, in they are starting with some initial zeros are there. So if you assume that that target has is having one leading zero, at least one leading zero, after that maybe E is there or F is there or any digit is there except zero, then it will reduce the overall target by 1 by 16. Right? Because zero means the first bit is zero, rest bit may be anything. But in the first bit, 1 to 9 and A to F is invalid. Right? Suppose for example, I'm telling another situation where the target has is having 8 leading zeros. Okay, so 8 leading zeros. So you know that the first four digits are zeros only. So in that case, the target has set is nothing but 16 to the power 64 minus 18. Okay, so the probability is 1 by 16. Here it is 16 to the power 64 minus 18. So if you find the probability of the random hash value, it is nothing but target hash set divided by the population hash set, where we know the population hash set is 16 to the power 64. But target hash set with 8 leading zeros, it is nothing but 16 to the power 64 minus 18. So if you calculate this one, you will get the random hash value, where the probability you can see 0 followed by 22 zeros and 2%, which is very, very minimal. So the chances of identifying the next value of the hash by changing the nonce are negligible, because you can see the probability is very, very less, and you need more computational power, which is not practically feasible. Now, coming to the process of Bitcoin mining. Bitcoin mining is of two types. Either it is a software mining or it may be a hardware mining. So generally, software mining is used when there are multiple people are involved. Like if you see big corporates of the world where multiple people are involved in the business, right? Or they are participating in the blockchain, there you can go for the process of software mining. But if you want to do it for individual, for yourself only, then you can go for hardware mining. So if you see, software mining is also again divided into two parts. It's called pool mining. Pool mining is nothing but a set of people connected to the network. They can also do the mining process. Like in a blockchain network, once a transaction is proposed, the miners has to verify that the transaction is valid or not. So we call that is a network of people. So they are going to decide whether to accept this transaction or to reject that particular transaction. And due to the shortage of computational power or graphics card, or you can say due to make it, you can say I want less energy consumption, less heat in the customer end, we rely on a third party. So the third party has to do that thing on behalf of the user, which we call as the process of cloud mining, right? Because this is not done in the client end, it is done in the provider end. Now, coming to hardware mining, you can use your CPU, which is less power in comparison to GPU, right? In order to process a particular transaction, right? Or in order to validate a particular transaction, or in order to do the process of mining. But GPU mining is more powerful because you have multiple ALU units in comparison to your CPU. CPU case you less ALU units are there, but GPU cases you have more ALU unit. Similarly, we have FPGA mining, that is called as field programmable gate array. FPGA chips are also there. Using that also you can do mining, or you can go for application specific integrated circuit mining. That also comes under the hardware mining, because these are nothing but the hardwares which is used for the mining process. Now, if you see in the process of mining, there are two important components we have. Okay, there is two important components you can find in the process of mining. One is called as proof of work, because through proof of work you make a consensus. Or through proof of stake also you can do consensus. The different mechanism is there, right? So POW is one of the popular method that is used in the Bitcoin. So what actually POW uses? POW uses a hash and a nonce value. Okay, I'll tell you an example to clear this idea later. So you have to take the hash value and you have to take the nonce value, through which you can make a consensus using POW. The second important component for mining is called as hash case. Okay, hash case, that is another important component that can be used for the process of mining. Now you can see also, if you look into this particular chart, this is showing a monetary policy, right? Like, if a miner is going to verify a particular transaction, the first miner has to get a reward, right? So how much reward the miner has to got, that depends upon this particular table. That's why the monetary policy is divided into two parts. One is called as block frequency, another is called as halving frequency. Okay, so monetary policy says that, like if you go for block frequency, a block is created in each and every 10 minutes. And in order to validate also, it requires 10 minutes. That is called as frequency. In each and every 10 minutes, we are doing that kind of processing. But if you go for this halving policy, so where the miners get 6.25 bitcoins, okay, upon validating a particular transaction. Like for example, here you can see, uh, in this particular block period, this block period is of for 4 years, 2021 to 2024. The reward value is 6.25, and you can see that price is again divided by 2 in the next 4 block period. That price is again divided into 2 in the next block period. Like that, if you process by 2137 to 2040, the reward value is 0, right? So in order to do faster processing, the miner has to verify that one, right? So for that, you are going to reward. But if you see early days like 2009 to 2012, so the reward value is 50, which is very, very high. Okay, there is some question. Let me address first one. Exactly, is there any difference between blockchain protocol and consensus method? Yes. My answer is yes. Blockchain protocol, consensus method, both are different. You are thinking that both are same, because you are thinking that POW is also a protocol, POS is also a protocol. But here blockchain protocol means, I want to mean that the network protocols are used in the case of blockchain, like HTTP, HTTPS, and other protocols like TCP, IP. These protocols are also used, right? But POW and POS, although it is also having a set of rules and regulation, but these are coming under the consensus method. They are not directly called as protocol, because I want to mean here that that is network protocols. As in some article, the author mentioned protocol as Bitcoin, Ethereum, where they are only cryptocurrencies. Yes, protocol means POW is a consensus mechanism, right? And HTTP is a protocol, right? Bitcoin, Ethereum, they are cryptocurrencies. They are not the protocol. But in order to make a transaction, you need Bitcoin, right? In what way you want to make transaction, that comes under the protocol. What exactly the difference between blockchain protocol, consensus method, agents of, okay? Is it clear, Sangeeta madam? Is it make sense what I addressed? Yeah. What I want to mean that the protocol means we consider the network protocol also. I'm not saying that POW, POS has not any having rules and regulations. They are having rules and regulation, but they are popularly known as the consensus methods. But they are not called as directly the protocols. Protocols mean we want to underlying technology protocol. That is nothing but TCP/IP, HTTP, HTTPS. Okay. So in each and every half year, we have seen that the price is reducing, and one day will come that definitely the reward value becomes 0. So at that times, miners are having also more computation power. So doing a particular computation is simply just writing a simple program, and you are executing that program. So it will not take much time. That's why the reward value is going to be 0 in the upcoming days. Now, here you can see in the case of POW, proof of work case, we have seen miners need to compete with other miners. So one miner has to compete with another miner, right? Who is going to compute it faster, right? So two miners, they will struggle to solve this, you can say, complex mathematical problem, which we call as puzzle, or you can say cryptographic ask function, because there is a competition, because whoever won that competition, he or she is going to be rewarded. But what happens sometimes, a malicious node, right, or a malicious person can add a block, and miner's computer needs 51 more potent than other machine in order to make in order to make validate a particular transition. Okay, in order to validate a particular transition, you need 51%. So sometimes what happen, a group of individuals, okay, whose sum, if you see, it is 51%, or those computer systems are having more power or more nodes, they can do malicious activity also. So they can group together, and they can also do the mining process, which we call the industrial size mining, where that total sum is around 51%. So they can do anything related, anything in the blockchain. But this violate the principle of the blockchain, especially the distributed ledger, which we also called as a 51% attack, right? Because 51%, if they compromise in the blockchain, then the entire blockchain can be compromised, right? But as the chain is increasing day by day, so we believe that 51% will not be do any kind of malicious activity in order to make trouble the entire network, right? So that's why we call that it is against the principle of distributed ledger, because 51% attack is not possible if more people are joined in the network. So here you can see I have considered three different type of blocks. In each and every block, we have a hash of the previous block, right? And we also having Merkle root. I'll tell you detail about the Merkle root, although this term is very popular, right? So we'll understand this term in more detailed way, right? Again, you can see the block one header. A block one header, we are generating a hash value. That hash is there in the next block also, like block two case also, you can get a hash of the previous block, Merkle root. So we are connected in a chain, right? So if any modification happen to a particular block, that block and its subsequent blocks is going to be affected. So here you can see, in order to go for hash case, first you have to pick up a particular transaction within a particular block. Like each block size, we assumed it is 1 MB, and 1 MB is more or less equal to 2000 transactions. So we are going to validate them and find the nonce for hash case and propose a particular block. But second step is called as finding a nonce and a cryptographic solution. The nonce is a cryptographic solution that is added into the block. In this way, the process of hash case actually works. So everything is maintained in the form of a block header. So let us understand what is there in the block header and what is the size of each and every block header. Like you can see here, each and every block header is unique and it is 80 bytes. Right? It is only 80 bytes. So if you see what is there in these 80 bytes, we have Bitcoin version number, that is 4 byte. We have previous hash value, okay, that is 32 byte. Merkle root is 32 byte. Timestamp is 4 byte. Difficulty target, it is also 4 byte. Nonce used by miner, that is 4 byte, and that is total. If you add these things, they are 80 bytes, right? So you can see these all informations are there in the block header. That's why I told you, if the node is not a full node, it is a lightweight node, it only contains this 80 byte information. It is not containing other informations. It is only focusing on this particular information, right? So now what we are going to do, like if you go for a hash function, as you know, in previous lecture also I told you, you can use different cryptographic hash function. Like in the Bitcoin case, we use this KCCAK 2256. Ethereum case, we are using SHA 3256. What these cryptographic hash functions are doing, they actually convert the data of arbitrary size to data of the fixed size. Irrespective of the input, the output they generate is the fixed size. Like if you can visit this tool, last class also I have shown you this particular tool. If you type different input, okay, even if you do some minor change, you will see the initials are also changed. Like I have typed my name, I have typed added in some case, I have added space. Some cases I have written in small letter. You can see their initials are completely changed. So you cannot say that suppose I am using 100, in next I'll use 101, right? For example, suppose I am writing a text XYZ, then I am writing suppose XYZA, then it is 101. Such type of technology is not there in the cryptographic hash function. If you do little bit change, it is going to affect your affect the uh, whole one, right? So that is called as your avalanche effect, right? Small change in the input is going to drastic change in the output. So you cannot map the input to output. That's why hash functions are called as your one-way function. Similarly, if you use SHA-3 256, which is used in the case of Ethereum, so there also you will see there is a small change is going to be a drastic change in the output. So there are different type of codings are there, and mapping is also very difficult. So it is practically very difficult to know by looking into a particular hash value what is its corresponding plain text. So that determination is very difficult. That's why this technology, this blockchain technology is relying on this one, right? That's why it is a very popular one. Now, coming to this Merkle root, it is very important. So, like we have seen that in block header, it is 80 byte information. Out of this 80 byte, 32 byte is for the Merkle root. So, as the name suggests, root, and if you are a computer science background person, you know when you go for a tree, we have a root, right? And a root may be connected to two different children. In the case of binary tree, again one node may be connected to two other children. Like that, they are processing from the root to the bottom, right? So Merkle root is nothing but the fingerprint of all the transactions in the block. Suppose 2000 transactions are there, they are a fingerprint. So the hash of these 2000 transactions are nothing but your Merkle root. Sometimes what happens, in order to secure the system or in order to enhance the security, a particular ID is hashed twice. They are not hashed only once, they are hashed twice. Suppose you are finding y is equal to f of x, right? Then you got y, then I am again saying f of y is equal to z. So if you can see here, the we have made two times hashing, right? So it will give you more security mechanism. Like in the Merkle root also, you can see like two different input is there. For example, this is my one input, this is another input. For example, this is one transaction T1, this is another transaction T2. So these are nothing but my input, right? So when you come to this block, I'm calculating hash of T1 comma T2. An individual block I can calculate hash of T1, hash of T2, but when you these values are coming here, I'm calculating hash of T1, T2. Similarly, if it is T3, T4, I'm calculating hash of T3. Here I'm calculating hash of T4. So here I will take hash of T3 and T4. And again, if you combine here, it is called as hash of T1, T2, T3, T4. So you can see the transaction T1 is hashed here one time, here two time, here it is three time, right? With other transactions, no doubt. So that is actually called as a Merkle root creation. Another example here, you can see here idea will be more clear. Yes, you can see it is represented just like a tree. We have set of nodes and we have leaves, right? So leaves are nothing but your transactions. Okay, and once you proceed from the bottom of the tree to the top of the tree, right? You will see multiple hashes, right? So new nodes are hashes of the lower nodes. For example, here T1, T2 is there. So I'm calculating H of T1. Here for this transaction, I'm calculating H of T2. So let's say the output is 0, 1 and here output is 0, 2. So whatever output you will get here, you are going to do hash of output 1 and hash of output 2. Let it be our output 1, 2. In the similar fashion, here you have two transactions T3 and T4. H of T3 you are calculating here, H of T4 you are calculating here. That is your output 3, output 4. I am calculating hash of output 3, output 4. Okay, this is output 3 and output 4. So we call that as output 3, 4. Again here, I'm taking output 1 to output 3 4 into constant, and I'm calculating it is output 1 to 3. So what you are doing is basically you are merging two different hash value to create another hash value. So that is done for enhancing the security in the case of blockchain. Okay, and hash value that is available in the root, okay, which is your 32 byte, right? It is nothing but a hash of that corresponding block, right? Leaf level you have transactions. Top level you have multiple hashes. Okay, after doing hash of this one, you are getting one hash value. That hash value you can consider the overall hash value of that particular block. Now, not only this hash case mechanism can also be used to identify the email spammer. Like some emails are not coming to inbox; it is going to spam box, right? So hash case is a cryptographic hash-based POW algorithm. For example, if you take an example, suppose you want to write a particular email. So if I ask you how much time required to write a particular email, somebody will say 20 seconds, somebody say 60 seconds, somebody say 1 minute, 2 minutes. So assume that the number of seconds or minutes that is required to write an email that is there in the email header. Okay, email is also having a header as well as the body part, right? So the average time required to write a particular email is encrypted and stored in the header. Let it be on average, it is minimum 20 seconds. Okay. So when an email is received by a receiver, first we are going to check the header part. Okay. And hash value is checked. Okay. If it found that after decrypting the header part, if we found that and the average time required to write this email is less than 20 seconds. Okay, because we have taken the uh, average one is 20 seconds. So minimum time is 20 seconds. So if it is lesser than 20 seconds, then an email can be classified as a spam. Okay, so it is going to be inserted in the spam box, not in the inbox. So let us take a detailed example to understand this one. For example, if I ask you hash for the previous block, assume that the hash of the previous block is this particular number, where you can see there are number of zeros in the beginning of this particular hash. If you count the number of zeros, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17, 18. So there are 18 zeros are there. Assume that you have total 100 transactions. The number of transactions is 100. Okay. Number of transactions what you have here, it is 100. Right. And let us take a random number that is 1, which is called as nonce. Okay, so in order to calculate the hash case, what you have to take? Hash case is depends upon hash of the previous hash of the previous block, which we call the previous hash. You need this nonce value. Okay, you also need the block of the transactions. So if the n transactions are there, we can represent it by transaction n. Txn means starting from the first transaction to tx capital N, which is the total number of n transactions. And once you get the hash of this value, if it is less than the target space, then only it is accepted, otherwise it is going to be rejected, right? So for example, if you applied SHA 256 here, and just a minute, you can see here. Yeah, here you can see once you get the hash value, you found that the number of beginning zeros are only 4. So if the number of zeros are only 4, what you can conclude here? You can simply conclude that this one is not matching with the hash of the previous block. That means SHA 256 is not yielding the right string for nonce 1, as the resulting string is only 4 zeros. This is only 4 zeros. So it is no way related to this particular previous of the, it is not equal to hash value. So what you have to do? You have to discard it, right? And if it is 18 zeros, then you are going to again check that the rest of the things are matching or not, right? But if they are having less number of zeros, you can simply discard it. So for example, I am trying with another nonce one is failed. So I am trying with the nonce two. When I use nonce two in place of nonce one by taking the hash of the previous block and set of transaction, that is nothing but hash of, you can say, nonce two. Okay, concatenation with the hash of the previous block, and let's say the transactions are tx and to tx capital N. So once I calculate this one, suppose by using SH256 cryptographic hash function, then I got let's say 18 zeros. So I'll compare with the rest one. Okay, so whether it is matching or not. Then otherwise I'll go for nonce 3, like that I will proceed further. Now, you know, nonce is also a 32-bit unsigned integer. So if you calculate the maximum nonce is 2 to the power 32. So 2 to the power 32 is, you can say, it is around 4 billion. Okay. So if you calculate the probability, it is nothing but 4 billion multiplied by, if you remember, we have already calculated target has target has divided by population has set. So there we got the value is 2 into 10 to the power minus 22. So if you multiply with 4 billion, you are getting, this is the probability. So you can see the probability is very, very less. But if you see the modest minor can create 100 million hashes per second. So if there are 4 billion hashes, I told you 4 billion nonce is there. Okay, then it takes only 40 seconds. So within 40 seconds, you can verify this particular miner, whether it is a valid one or not, and it can return that particular thing, right? But the probability is very, very less because not only one transaction occur, but there are several transactions are there. There is another mechanism that we are using in public blockchain system that is called as timestamp. It is also called as your current Unix time. It is nothing but represented in the form of second. That is the number of seconds passed after 1st January 1970 is considered as your timestamp, and it is a 10-digit number. So you can see we have nonce, we have a 10-digit number, that is timestamp, we have hash value. By combination of these things, you will see it is difficult to uh, do any kind of malicious activity in the blockchain process. Now we'll proceed towards the mempool, which is also very important. So here I am showing you in a mempool, right? You can see the number of transactions. Like here, you can see the 9 different transactions are there. So this mempool consists of your 9 different transactions. So these transactions are called as your unconfirmed transactions. So these are, you can say, yet to be added into the block, okay, or blockchain, right? But till now it is not confirmed. That's why they are put in the mempool. So if you look into each and every transaction, the transaction has a transaction ID, okay, which is represented in the form of 7 hex digit, and fee for the miner. Means if you validate this particular transaction, then the first miner has to get 0.00013 Bitcoin, right? But miners are very clever, so they know that why to go for the transactions which are resulting less fee, right? So they always choose the transactions which are having highest fees, right? For example, if I ask you, look into these 9 transactions, 1, 2, 3, 4, 5, 6, 7, 8, 9. Can anybody tell which transaction is giving you highest fee? Can you identify which transaction is having highest fee? Anyone from audience? Look at these 9 transactions. Which transaction is having highest fee? Because miner has to pick the highest fee transaction. Please look into this mempool and identify out of these 9 transactions which one is having highest fee. Because miner will choose this particular transaction first. Quick, anyone in from the audience participant? The last one, exactly. Okay. So you can see last one is selected, right? Generally, miner has to process one transaction only. But if I assume that miners can pick five transactions, because total 2000 transactions are there in a particular block of 1 MB. So if I ask you to five different transactions, then the next highest transaction you can find this one 0122 0139. Okay, the next one you will get, I think, 139 122 111. If you choose best five, it will come 0093. So five different transactions we have selected from the mempool. So if a miner wants to verify the transactions, and at a time, let's say it can verify five different transactions, then it will choose the five best transactions. While this miner is choosing this one, another miner can choose another other transactions also in order to make it confirm. Because there is a competition. That's why I told you one miner has to compete with another miner in order to in order to confirm a particular transaction. Okay, what they will do after this? Like here you can see, let us see this particular data set one from the mempool. For example, I am choosing the highest transaction. Okay, let's say I am choosing one transaction randomly. Let's say this particular transaction, and I am matching with the target hash, because the value should be less than or equal to target hash. Otherwise, it is going to be discarded. So if the test hash does not match with the target hash, we are simply discarding it, right? For example, this particular transaction, okay, uh, it is not matching with the target hash, okay, because it is not less than the target hash. Then what you will do? I have to replace this transaction with another transaction. So while choosing another transaction, here you have selected five different transactions, right? So that five different transaction appeared here. So you have to find the sixth transaction, which is having highest amount. If you look into the sixth one from this particular list, except these five. So here you are getting 0021, here you are getting 0013. It is 000023, 000013. I think you will get this one. So transaction ID is 9728T80. You can see we have replaced the top transaction with this particular transaction, right? So we have selected five transactions, but we found that out of these five transactions, one is not matching. So we have discarded it and we have selected another transaction. Now you can see again you are checking with the test hash is equal to target hash, right? Suppose again it is not matched. This one is not matched. So you have to choose the next highest one, right? The next highest one, if you see out of these three, it is 0.0013. Because here you can see there is 20, here you have three zeros, right? Obviously it is better. And the transaction ID is DA3B430. So you can see here DA3B4030 is inserted into the mempool or memory pool. Right. In this way, memory pool the transactions are updated. If for a particular combination the test hash is equal to target hash, then it is added into the block, otherwise it is removed from the mem block. Right? And assume that if a particular transaction is having fee is equal to 0, like here you can look into, there are five different transactions and their fee values are written. For example, the fee value is equal to 0. Then what will happen? Fee value is equal to 0 means it is highest priority or lowest priority. Can anybody say? Fee is equal to 0. Is it higher priority or lower priority? There are five different transactions you are looking here, right? Suppose in one case the fee value is equal to 0. So whether the miner has to take it is as high priority or miner has to choose this is a lower priority. Lower priority definitely, right? Okay, because that transaction will never come because they are always competing each other to get the highest one. Because highest one will reward them more. That is the reason why it is having lower priority. That's why the transaction fee is 0 means the transaction may stuck in the memory pool. Right. In fact, also in Bitcoin we say if there are less number of if the transaction amount is less, then confirmation required is very less. Okay, no need to confirm with everyone. I'll show you that also, right? In a particular slide. Okay, now proceed further, then how this mempool works? So mempool is attached to the each node. Okay, they are not a part of the blockchain. Like if you consider these are the nodes, the mempool is attached to the node. They are not a part of this blockchain. Okay, and a mempool can have 10,000 transactions at a time, right? To verify, but they are taking one transaction at a time in order to compete with other miners, right? And every fortnight, right? If you go for every fortnight means it is 2 weeks, right? After 2016, after 2016 blocks, the Bitcoin server is reconfigured such that average time taken to create the next block is 10 minutes. But if you go on chain, then the time will increase, right? So in order to avoid that, the server is reconfigured every 2 different week. Now come to another important concept in public blockchain system, that is called as block propagation and relay. So it is very much important. Here you can see how many people has to confirm a particular transaction to aid that transaction into the blockchain. That is very much important. So based upon that, this confirmation of the transaction is of two type. One is called a zero confirmation, one confirmation, another is called a six confirmation transaction. So zero conduction confirmation means you want to submit a particular transaction as a user, then other party blindly believes you, right? Because the amount is very less, so no need to do no need to uh, put more focus on that particular transaction. The user submit a transaction in zero confirmation transaction, and other party accept the same with minimal verification, you can say. But when you go for one confirmation transaction, if the amount is less than dollar 1,000, then one confirmation is sufficient. So receiver has to wait until unless at least one node has to confirm the transaction is valid. Once you get, then it is confirmed, right? And in between 10,000 to 1,000 to 10,000, you have three confirmations are required. Receiver has to wait up to at least three different nodes to get confirmation. Similarly, six confirmation transactions, so which is a general rule of thumb. So maximum cases we are doing six confirmation. So we are waiting for six different nodes to confirm a transaction is valid. Although the amount is written like this, but maximum case we are using six. But if the amount is much more higher, like you can say dollar 1 lakh, okay, or dollar 10 lakh. So in that case, you need 60 different nodes to confirm that transaction in order to make it fixed in a particular blockchain. Right? Now, if you compare the Bitcoin with Visa and Mastercard, so ATM card we are using either Visa and Mastercard. Nowadays we have Rupee cards also. So if you can see the number of transactions per second in the Bitcoin is 7. But if you go for Visa and Mastercard, the number of transactions per second is quite more, 65,000, 40,000. Okay. And number of transactions in the year of 2018, if you see, Bitcoin is having only 81 million transactions, where Visa and Mastercard is having 124 million and 74 million billion. This is in million; these are billion, respectively. So what we can learn here that, as I mentioned here, every transaction need to minimum 10 minutes to confirm. So it is a properly a time-consuming process. Now, there is another important concept you can see in the public blockchain system, which is nothing but called as orphaned block. Okay, like this is a completely distributed system. So you are adding one block to the existing block, right? So sometimes what happen, multiple blocks are ready to added into the block. So one of the block is going to be accepted. Other blocks are called as a orphaned block. So let us see with this example. So whether it is a orphan block or a normal block, both are valid blocks only. But orphan blocks are not part of the main chain. Okay, temporarily they are not part of the main chain. But once it is declared as orphan, then it is again sent to the mempool, and from the mempool again it is going to come to the part of the blockchain. But they are not directly the part of the blockchain. Like here you can see XYZ, okay, added a block in 1st July 2019. and the timestamp mentioned is 22, 9 and 31. Number of transactions in that block is 1978. So XYZ is successfully added a particular block. The block number can be 603765 with these particular details. Now, later point of time, ABC is another block added to as a next block of this one. Okay, and the timestamp is 22 9 11. That means 10:19 p.m. Right, and on the same date. The same date, another block is added into the blockchain. But what happened immediately after 11 seconds? Like here, you can see the time is 10 19 11. Okay, the second is 11 second, but here you can see the same time is written, but the second is only 11 second ahead, right? So there is another block DF with 1820 transactions. So now you can see ABC and DEF more or less they reached at the same time. So they are two minors. They claim the same block number, that is 603766, which is the next block of this one. Okay, like we have seen Genesis block, block 1, block 2, block 3, and so on. So both blocks are now claiming that they are having the same block number. So what to do here? So we have to see that the blocks with ABC or DF will continue to grow. Again, this block is going to also grow, and this particular block also is going to be grow. So we'll have two competing blocks at the same time. Just like you can say earlier you have one blockchain, now it is divided into two blockchain. Similarly, again, this if there is something happen, it is divided into another two blockchain. It is also divided into another two blockchain. Okay, but blockchain says that there is a single chain, right? But there should not be multiple blockchain, which I am illustrating here. So the in order to break this one, there is a golden rule which says that you have to go for longest chain. Longest chain always wins, right? So we'll say ABC and DF. Out of these two, whoever builds the next block faster will take over the chain. If ABC is going, it builds the next block, so ABC has to continue, right? If DF has to add the next block first, then DF has to continue. So suppose ABC has continued, right? For example, ABC has continued, and the new block added by ABC is 999, which is having next block number, that is 603767, which is next of this 603766. So what we can do, what we can say here, the DF is not grown, right? So we consider the DEF as a orphan block. Okay, that is transaction, whatever transactions we have here, like 1820 transactions are there, they are again moved to the memory pool. Okay, so it is declared as a orphan block or detached block, and again it is back to the memory pool, so that once it is ready, again it will be part of the blockchain. But again, in order to avoid two different chain, we have declared this one as a orphan block. Now, the next point of discussion is coming the Bitcoin script. I will show you two scripts as I told you. So there is a very popular programming language that is called as Forth, Forth. You can install it also. You can install its IDE also, and it is used to write the Bitcoin script. Like you have studied microprocessor, you have seen different kind of microprocessor: 8085 microprocessor, 8086 microprocessor, 80286, 386, 486, like that. You have seen different microprocessor. Here, the Bitcoin script is have this fourth programming language is having 256 instructions, and each instruction is of 1 byte. But in the microprocessor case, you will get 2 byte instructions, 3 byte instruction. Okay, but here you will get 1 byte instructions. Out of these 256 instructions, 15 instructions are not in use, and 75 instructions are reserved, right? And some of the popular characteristics of this Bitcoin script is that there is no loop. You will not find any while loop, for loop, but the syntax is more or less same as our any traditional programming language which we have come across, and it is stack based. So whatever instruction you are doing, one instruction is above another instruction. That's why we call this a stack based, and it is very simple to execute, and the instructions are lightweight instructions, and it consumes less energy. And you can also validate multiple nodes supported using multi-signature instruction. Multi-sig instruction means you have more than one signature. I'll show you the code for this multi-sig instruction so that you can easily understand. Now there are two type of instruction you can find in the Bitcoin script for. So they are called as data instruction. Second one is called as opcode instructions. Data instructions are the instructions that is represented in the form of angular bracket. If any instruction is enclosed with a angular bracket, open angular bracket, close angular bracket, that is called as a data instruction. For example, I can write SIG. SIG stands for signature. PUB key stands for public key. PUB key has indicates public key has, right? Similarly, if you go for other type of instruction that is called as opcode instructions, it is starting with the keyword OP, right? For example, if I write OP underscore DOP, indicates DOP stands for duplication. Okay, OP has 160. You know, this is a cryptographic hash function. OP underscore equal verify. If you want to check X is equal to Y or not. So you can use equal verify. And OP underscore check sig, that is check signature. So these are the two different type of instructions you can find in the Bitcoin script. So let us understand two different. Let us take two different script and understand how actually this fork programming language considers Bitcoin and how it applies the different kind of instructions to in the computer, right? So I have written a very simple script here. You can see SIG pop key. So they are angular brackets. So you can say these two are called as a data instruction. This is also a data instructions. But this OP part, this is called as your opcode instructions, right? Because they are written starting with OP underscore. Okay, so let us evaluate this particular script. You can see first one is SIG. SIG is signature. So as I told you, this is a stack, right? First, you need to put a signature into the stack, right? Initially, your stack is empty, but now you put a signature inside the stack. Now, in the stack, you have added another data instruction, right? That is called as your pop key, right? On top of the signature, you put another element that is called as pop key. What actually it indicates? It is indicates signature. It is indicates your public key to verify the signature. Why public key is important? Public key is also used to verify the signature. We have seen there is a public key and there is a private key in asymmetric cryptography. So you need to verify that signature. For that you have added it. Next one is we'll execute OP underscore DUP. As I said, duplication. So this is our stack content till now. We have signature, we have public key. On top of this one, I have added OPDUP, which is a opcode instruction. So it is going to duplicate it, right? OPDUP means what? It has to duplicate the public key. So you can see after OPDUP, the stack content is signature followed by public key. OPDUP just taking a copy of this one added into the stack, right? That is called as public key. So OPDUP is used to push a copy of the public key into the stack, which we have seen here. Now the stack content is signature followed by public key followed by public key from the bottom of the stack to the top of the stack. Okay, the next symbol, next one is called as OP underscore hash 160, right? Now your stack contain this one, right? You have signature, public key, and another public key, right? On top of this public key, you have OP underscore hash 160. So the purpose of OP hash 160 is to pop, right? It is going to pop the top value of the stack. What is the top value of the stack? Top value of the stack is nothing but your public key, right? And it is going to compute the hash and pushes the result into the stack, right? Once it is calculated, it is going to push that into the stack. So it is remove public key, right? It is removed public key. Okay, it is done computation, and whatever result it is coming, let it be PK hash, right? That we call as public key hash that is added into the stack, right? Initially signature is there, public key is there. One public key is removed by OP hash 160. Then it has inserted as a result of PK hash, right? Then we have written public key hash. It is again you are pushing another public key hash, okay, which is nothing but a duplicate of the previous public hash, right? So that you can compare these two. So public key hash pushes the public key to the top of the stack, ensuring the duplicate one. Okay. Now the next instruction is OP underscore equal verify. So it has to check whether these two public key hash is same or not. So if these two public key hash is same, then it will cancel these two. It will say yes, it is true, right? It matches the hash generated within a given hash. If it is equal, then it has to remove. Now you are left with what? You are left with the three things. One is signature, public key, and the last symbol, last opcode instruction is OP underscore check sig. What it is going to do? This returns the signature, right? If the hash generated with the given hash. So I told you the hash it should be less than the target hash. If it is there, then it is returning the true as a output. Otherwise, it will return as a failure or false. So basically, this particular one pushes the value as true onto the top of the stack when the signature actually matches with the public key. Equal verify is checking these two. Then you are having public key and signature. So we are, if the signature is verified, then it is going to return true. Otherwise, it has to return false. This is one of the Bitcoin script. Let us see another Bitcoin script. Okay. So in this Bitcoin script, you can see I have given only 5 different instructions, which is very simple. That is nothing but addition of two number and verify that whether the addition is correct or not, right? So OP underscore 3 is our first instruction. What it indicates? You have to consider a stack and you have to push the value 3 into the stack, right? OP3 means opcode instruction. You have to 3. You have to push 3 into the stack. Now when you OP2 is detected, so you have to continue with this stack. You have to insert 3, then you have to insert 2. OP2 means push the number 2 into our stack. Right? Your earlier our stack is having 3. Now we have added 2 into our stack. Now OP8 says that you have to add these two, right? 3 and 2. Then I can write here OP underscore add. What OP8 is going to do? It has to add these two. Okay, it has to pop the two element and perform the sum. Again, whatever sum is coming, the sum is 3 plus 2 is 5. That is going to be pushed into the stack, right? Now, what is our next statement? The next statement is OP underscore 5. That indicates that 5 is already there in the stack. So you are pushing another 5 into the stack. Okay, up to OP8, this is your stack content that you have added 3 plus 2, that is 5, that is added into the stack, right? OP underscore 5 says that you have pushed another 5 into the stack. Now the last instruction says OP underscore equal. So the stack content is 5 and 5 and you are checking OP underscore equal. So it has to pop two values from the stack and check that both values are same or not. So if you pop these two values 5 and 5 and if you compare you will get 5 is equal to 5. So this one will return as a true, right? If they are not equal it will return as a false, right? So in this way you can write a simple Bitcoin script and write a small code in the fourth programming language by the help of the data instruction as well as your opcode instruction. So as you see, data instructions are nothing but here. Is there any data instruction? If I ask you any question, there are five different instructions as there. Is there any data instruction here? How to identify data instruction and how to identify opcode instruction? Is there any data instruction? First you answer yes or no.
No data instruction.
Yeah, there is no data instruction because there is you have not seen any angular
Angular
bracket
bracket.
here. Yeah. So Next one is your opcode instruction. Yes, there is all instructions are opcode instructions because they are starting with the OP and underscore followed by some instruction, right? So this is all about Bitcoin script. The last part is in the public chain system, public blockchain system is that how to make a transaction in the Bitcoin network. So like we are making bank transaction, in the bank transaction also they are keeping some reference number, they are keeping the timestamp, account number and other details, right? So a transaction consists of the person number, okay? And we have seen also in the header part, right? As I mentioned, header is we have discussed the blockchain header, right? Blockchain header is 80 bytes. So in that I told you version number is 4 byte. Okay, there you are keeping version. Like if you go for network also, we have IP header. You know, IP is either IP version 4 or we have IP version 6. So by looking into header, you can easily say whether it is a IPv4 address or it is a IPv6 address, right? Similarly, here we are maintaining version. We are also maintaining input, output, and this log time. Right? Some unique time we are maintaining, right? And this input and output is very much important, right? So one transaction is connected to another transaction with this input and output. For example, transaction zero, if I say this is a transaction zero, it has also four different component. Okay, person, input, output, and log time. Transaction one also having four different component, right? So transaction zero's output are input to the transaction one. Similarly, transaction one output is returned to transaction two, and so on, right? But it is not necessary that all the things you are going to convert from input to output, right? There are some things you have not computed, right? So output indicate the unspent transaction output, which you represented UTXO, okay, from the previous transaction. If something is not carried out in transaction zero, simply you have to put UTXO, that is unspent transaction output, so that we are trying to solve that in transaction one. If not in transaction, again in this output file, you will keep to transaction two and so on. So this process is simply repeated in order to forward one transaction from one transaction to another transaction, right? Like for example, if you see, suppose Anand, who is a sender, needs to pull out Bitcoin from four different transactions, and the transactions are TX0, TX1, TX2. So you can see TX0, TX1, TX2, TX3. These are the four different transactions. So what happens? These four transactions are given input to the TX input. The TX input is nothing but sum of these four transactions. So again, if you are making a particular transaction, then definitely there is a transaction output. TX input is there means TX output will be there. But if a particular transaction is not computed, like you can say I have used TX0, TX1, but these two are not computed. So I can say these two are called as your unspent transaction output, which we call as UTXO. Unspent transaction output, right? TX stands for transaction, U stands for unspent, O stands for output. So that change let hour will be there. It will be moved to the next transaction. Like that, the process is continuing. So for a valid transaction, what you have, you know, suppose you have 50 rupees, we have seen in database, right? You have 50 rupees, okay, and I have, let's say, 70 rupees. You want to transfer 20 rupees to me. So my content is 90, your content is 30. So before transaction, the sum of both balance is 120. Here also sum of the balance is 120, right? So in order to make a valid transaction, TX input should be greater than TX output, right? If amount whatever you have that is more and what the amount you want to spend it is less, then only it is valid. And if there is any difference, that is also considered as a transaction cost. That's why I have written only greater than. You have 10 rupees, you can spend 10 rupees, okay, but I'm writing 10. Suppose you want to spend only 9 rupees. Why I'm writing 10 less than 9? Why not 10 less than equal to 9? Right? Because is that there is some transaction cost is also there. When you are making a particular transaction, not only you are transferring, you have to pay the transaction fee. So basically, this fee is taken by whom? It is taken by the first miner. right? So transaction fees of the Bitcoin can be calculated as transaction input minus of transaction output plus change left over. Suppose you have spent you have 10 rupees, right? You have spent 7 rupees, okay, and transaction left over is 2 rupees. So 7 plus 2 it is 9, 10 minus 9 is 1, so transaction fee is equal to 1, right? But in if one particular case transaction input is less than transaction output, that means you have 10 rupees but you want to spend 20 rupees. Is it possible? No. That's why you have to reject such transaction. Okay, now let us see whatever we have discussed. We'll take with an example. Suppose there are four transactions here, right? One is, you can say, one person is called as Mure. She want to transfer some amount to Monica, right? 0.6 BTC. And then also wants to transfer something to Monica, that is 0.5 BTC. Bobby wants to transfer to Monica 0.3 BTC. Karin sent to Monica, that is 0.2 BTC, right? So sum of these BTC is how much? 0.6, 0.5, it is 1.1, 1.4, 1.6. Okay. These are called as on-spent transactions for the output Monica. Suppose all the transactions are successful. Okay. So now Monica is having how much amount? It is having 1.6 BTC. Okay. Now, later point of time, suppose Monica decided that she wants to buy a car, let's say for 0.9 BTC. Okay, assume that it is 0.9 BTC from a particular vendor ABC. So, what is our input? Our input is having four transactions that we have seen in the previous slide. These are the four different transactions, right? So, I'm picking two transactions, right? And this is my input. These two 0.6 BTC, 0.5 BTC is my two different transactions. What is my output? My output is that I have to give 0.9 to the ABC company. Monica has to pay, right? So that is included in my output. But this sum is 0.6 plus 0.5, it is 1.1 only, right? So 0.9 means you are left with another 0.2 BTC. So it is possible if we assume that the transaction fee or transaction charge is equal to 0. Otherwise, it is not possible, right? So fees is considered as 0. BTC. So I am removing these two transactions from UTX0, right? And the remaining transactions, leftover transactions, will be forwarded to the next one, right? Now, later point of time, again, Monica decided to buy some goods from Amazon of cost 0.4 BTC. So you are left with how many transactions? You are left with these three transactions: 0.3, 0.2, 0.2. So 0.7, and Monica is left with 0.2. So we can say it is 0.9. So now what you will do here? 3 BTC and zero point 0.2 BTC, and output I will provide 0.4 BTC to Amazon with a transaction charge of 0.1. Okay, because input you can see here it is 0.5, output is 0.4, so the difference between these two is 0.1 BTC, which is considered as a transaction fee. Okay, again two transactions we have deleted. So after successfully computing this thing, the wallet of Monica is having only 0.2 BTC, right? So Monica sent to Monica means you can see here. Earlier we calculated is 1.1, but this one is 0.9, right? And 0.2 BTC is there with Monica. So that is there in the wallet, which we call as Monica sent to Monica, that is 0.2 BTC. So in this way, different transactions are maintained and they are calculated in the case of blockchain. But if these transactions are maintained in such a particular format, then easily one person can hack it. And by reading this transaction, one can easily understand who sent to whom, right? But if you maintain a distributed ledger, again, it is difficult, right? Because if any modification happens, then definitely um, you can easily identify where it is identified. But again, even if it is stored in the distributed ledger, the main problem with distributed ledger is there is no privacy, right? Who is sending to whom? It is known to everyone. That should not be good. So there is no privacy. So we can solve this problem by digital signature, which we have studied in my first lecture, where you have a pair of public key as well as pair of private key. So by taking the combination of public key and private key, if you save these particular transactions, so that will help you to solve this particular problem, and nobody will know about the information, so it is not violating any particular policy, right? Privacy is well maintained in that particular policy, right? So in this public blockchain system, we have discussed these things. As a conclusion, I will say we have seen what is the difference between public and private blockchain system, and we have seen in which case you can use public permissionless, public permission, private blockchain system, or in which case you cannot apply blockchain at all. Then we have seen there are three different layer of blockchain. We have seen different blockchain mining process like hardware mining and software mining. We have seen pool mining, cloud mining, CPU mining, GPU mining, integrated you can say FPGA mining, ASIC mining, and also we have seen Hashcash and POW. We have seen two examples of Merkle root. We have seen that how the transactions are done in the case of memory pool. We have also discussed about zero confirmation transaction, one confirmation transaction, two confirmation transaction, and we have seen two examples with respect to Bitcoin script. And the last one we have discussed how to make transaction with Bitcoin network. So these are the references. So thank you everyone, but I'll tell you the practical part in rest of the time. We are left with another 15-20 minutes. So let us do some hands-on so that we can relate the theory with the practical one. Okay, I request all of you to open Google Colab. So there is no need to install. If you have installed Python, then you can use your IDE like PyCharm, Anaconda, and other things. Otherwise, you simply go to Google Colab. Suppose I want to create a new one. Let it be a new notebook, and the name of the new notebook is demo. Okay. So all of you go to Google Colab and simply create a simple document which will help you to write the code, or if you have any Python IDE, you can directly use that Python IDE. So in order to generate a random key, so I'll give you a link actually in the chat box. There is a GitHub link. You can refer to this GitHub link. I will share this link in the chat box where you can practice something related to blockchain. Yeah. So here you can see there is a set of functions are there. Like, without writing a long code, you can use the functions. Some of the functions are written here. I'll also explain while writing the code. So suppose you want to take, there is a package that is called as Bitcoin, right? You have to take that one. Suppose I want to write for Bitcoin import star. Okay, or if you are using any ID, so import the package Bitcoin, right? And in order to install, if it is not there in the system, you can also write pip install then Bitcoin, right? So first time it will execute, the rest of the time you can use that package in Google Colab, right? So in order to generate a random private key, suppose I am taking priv is the variable, then I'm writing random underscore key. Okay, it is going to generate a random key and store that key as a private key, right? And suppose I want to print that private key, so I'll write here print the private key. Okay, so if you run it, then first time it will install this particular package, that is Bitcoin. Then it is imported. Then random key is generated and it is stored in private, and we will print the private key. Right? You can see looking for indexes, downloading Bitcoin, successfully built Bitcoin, installing collection package that is Bitcoin. It is one-time process only. If you are using ID, it is one time, but in Google Colab, whenever you open a new document, you have to write like this, right? But next run, it will not ask you. and you can see successfully installed Bitcoin. So at the end, you will get your private key. Okay, I'm pasting this in the chat box. Okay, it will print the key. This, I think it is running again. Let me run it. Yes, you can see this is the private key you are getting, right? You may get a different private key in each and every run because you are considering the random key, right? Each and every time when you run, you will get a different key because the private key is going to change because you have taken a random key here, right? This is a very simple code. Then suppose you want to convert the private key to the public key. You can go to this page here. You can see there is a function, right? Private to public. It is a method, private to public. So let us do that one. So what I can do, I will write priv to public, and I will supply this private key as a input parameter, and let me save in public. Okay, and I want to print the private key. Sorry, I want to print the public key. Here you have printed the private key. Here it is a public key. So public key is more size in comparison to the private key. You can see here. So this is your private key, right? And this long one is your public key, right? So you can try this code also. Will also paste the output. You will get a similar output as you have taken the random one. Then you can see the code is your output is different from my output. Okay. Now, if you want to go for another function which is called as public to address, private to address, that also you can do. For example, let me write another one that I want to do public to address. Okay, that is PUB. Okay, so let me store it in a address addr, any variable you can write. And if I want to print the address, that is addr. Okay, so if you run it, then you will see the public key as well as private key as well as the address. Okay, so you can see the first one. You can if you write a comment here. Suppose I want to write here private. Suppose I want to write here public, so that big message you will get. So it is more meaningful. Now you can see private is this one, right? And public address is long, and address is this one, which you have converted public to address. Similarly, here you can convert private to address also, right? I am copying the same code, and instead of public, I am writing private. Private to address. I can say it is public to address. It is private to address. Okay. What is the input you have to take? I think a private input you have to take. Let me check. Yeah, now it is working. I have given public address as a input. That's why it is showing error. Okay, I am testing the chat, the output also. You can see one important thing here. The last two address is same, right? Because while you convert the public to the address or private to the address, you will get the same thing. In this way, you can making match the output, right? Once it both are same, then only you have to accept it. Otherwise, you have to reject it. Okay. Suppose you want a particular specific input. Suppose I want to write my name instead of doing any random key, generating any random key. Suppose I want to use SHA-256 as my cryptographic hash function, and I'm writing my name. You know, irrespective of your name, it will be given you a 64 bit, right? 64 hex digit. So once I run it, you can see this is the private one, all right? And this is the public one, and this is the private one. It one more time, you are getting the same thing, right? You are getting 57E26. Here you are getting 1 EAH. Any number of time if you execute, you will get the same thing because your input is fixed. So input to output, it is a one-to-one matching. But if there is a small change in the input, that is going to be impact in the output, right? So with that, you can write the code, and this is your output. Okay, if you want to generate the hash digest also, there is a function given here that you can use. Uh, you can see there is a lot of functions are there. You can try whenever you are free. You can try these functions and make practice of these functions. So there is another library that you have to import that is called as import hash library. Okay, through which you can generate the digest. Suppose I am writing X is my name. Okay. Then as a output, suppose I want to get hash, I want to use this hash library, and I want to use SSH256, and this input you have to encode, and you have to use hex digest. That will give you the hex digest value, message digest value, right? So if I print this output, okay, you can see you are getting here the value, this one. Again, this value is an unique one. Irrespective of your run, you are going to get the same value. Okay, but this function, this haslive.sh is under the import the library, hash library to use it. With that, you can try. Okay, the last program just I want to tell you, that is, I told you about multi-signature, right? That also you can try with here. There is a function. For example, if you generate multiple keys, for example, let me go to the previous code only. I'll do a little bit modification in that code. Yeah. So here, suppose I want to generate multiple keys, right? For example, I will write public key 1 is equal to uh, private to public to generate a random key and convert it to public key. This is my first public key. For example, I want to take another public key, then this private to public random key. Okay, same thing I'm writing, but I'm creating multiple public key here. Okay, so these are the three different key I have used. So I told you multi-signature, right? There is a function here you can find that is you can see here, yes, mk underscore multi-sig address. This one, this function is used, that is going to return your m of key. For example, if I use here this particular function, let it be stored in multi. This is mk multi-signature address. Or you can use also the script also. There is another function that is called script. So there you have to mention all the keys like public one, public two, public three. These are the three keys. But I'm writing 2 comma 3. 2 comma 3 indicates I'm selecting two signature out of three. Then I will get m address suppose is equal to, if I write in script address. So it is going to return you the script address of this multi signature. If I print m address, you will get multi signature. Okay. Oh, yeah. You are getting here a multi signature. Okay, like that, there are so many functions are there. Once you are comfortable in this, you can write a simple code. Although some codes are already given in this link, you can explore these codes so that if you are interested in this blockchain field, so you can try with these examples, which will help you to get expertise in this particular field. Okay, so we'll stop here. This is all from my side. If you have any